Okay, here's section 5.2. So we're looking at circular motion and Newton's laws. Really, we're going to look at like acceleration, speed, all of that when it comes to circular motion. Okay, so first off, looking at period and frequency, okay, of circular motion. So like when a pitcher throws a curveball, spins the ball so it makes that curve. Okay, it talks about this a little bit in your textbook. Okay, but basically the period is like we represent with P is the time it takes for one revolution. Okay, the velocity would be how fast the baseball's spinning and so on. So like period is from here to here, one full revolution. Okay, how many seconds it takes per cycle. Okay, frequency is the inverse of your period or your time. Whoops, sorry. Okay, and so frequency is how many cycles per second. So they're just the inverse of each other. Okay, and so you can find both of them using like these two formulas. So T equals 1 over F. Okay, frequency is measured in hertz. Yeah, so rotation, one cycle. Period is T, that's the time required to complete one cycle. Frequency is number of cycles per second, measured in hertz. And short form for hertz is just Hz. Okay, period and frequency are reciprocals of each other. Okay, and so that's, you can just use this 1 over T to find frequency. Another way to do it is just on your calculator hitting the x to the -1 will give you that number also. Okay, so yeah, unit for frequency is hertz, Hz. Okay, and basically 1 hertz is 1 over seconds, or seconds to the -1. Okay, named after the scientist Heinrich Hertz. Another way that frequency is measured is in RPM, or revolutions per minute. So to go back and forth, okay, you can just follow this, but basically hertz you times by 60 seconds in a minute, and for RPM you would divide by, or like times by the inverse of this, or divide by 60 seconds in a minute. So different things that we might like look at for revolutions, things like a hard drive. Okay, it's going so fast that like the period is like what is it? 0.00833 seconds. So it's such a small number that makes it a lot easier for us if we get that in hertz. And so in hertz, that would just be like 120 hertz would be the revolutions on this hard drive. So it spins around 120 times in a second. Okay, and so depending on like one or the other, like how long it takes us to go one revolution around the sun, we'd measure that in a time period, 365.24 days, instead of in something like hertz, because we don't like, that's such a small number in hertz. Okay, now looking at speed and circular motion. So again, the formula for constant speed is velocity equals change in distance over change in time. The distance, okay, that we're talking about when we're talking about circular motion is the circumference, so the distance around the circle. And to find that, the formula for circumference is 2 pi times the radius of our circle, okay, which we have here. So that's why distance is equal to 2 pi r, because we're looking at the distance we're using is our radius, and then the time is capital T, because that's the period, how long it takes to go one revolution. So this is the formula we're going to find for constant speed. Okay, and yeah, how they're measured. Remember, radius, meters, time in seconds. Whoops, got ahead of myself there. Okay, and so like, and there's examples in your textbook. All of these kind of showed an example based on this. So if you're looking for this velocity, this is your radius, you'd want to convert that to meters, and then you can solve for that, which it's done in your textbook. Okay, for acceleration, okay, or centripetal acceleration, okay, you want the speed. Okay, and the reason that the speed is squared, okay, is because let's look at, like if you're looking at the change in speed, okay, basically, yeah, you end up with speed squared. Okay, or really what you look at is it's all done for you on page 253 and 254. It's kind of 5 steps to get this formula. Really, this is the formula you're given in your on your data sheet, so that's what you'll refer to. You don't have to kind of show how it was solved, but it's using, yeah, like our 2 different like change in speed over change in time. And again, change in speed would be our velocity times our distance, change in distance divided by r, and then our time would be change in distance over velocity, and we'd end up with this formula. Okay, again, always make sure we are in meters per second squared, meters per second, and meters when we're finding acceleration. Okay, and yeah, just another example that's in your textbook on how to solve for this. Okay, and then putting that formula and putting a couple formulas together, again, for if we're finding force, force is always equal to mass times acceleration. So now when we're looking for centripetal force, okay, it's the mass of the object times the acceleration, the centripetal acceleration. Okay, and so if we have the acceleration, we just times it by the mass. If we don't have the acceleration, we can just use our acceleration formula, which is v squared over r times the mass. Okay, and that's the formula you're given. Well, actually, you're given both of these formulas in your on your data booklet. Okay, and another example is in your textbook on how to solve for that. Oops. Okay. Okay, the horizontal system in circular motion. Okay, so we have basically our different forces that are pulling on. So if a car is going around a circle on the road, okay, it might not be a circle, but like going around a curve. Okay, we have our center of our curvature. Okay, the force of friction is kind of what's pulling it, and the force of friction of the tires on the road, okay, is the centripetal force. So the FC equals our force of friction. Okay, and so again, when we're kind of setting it up, we make everything going up positive, outward positive, or east positive, and then down is negative, and inward would be negative. Okay, and so since we know that our force of friction, okay, is equal to our centripetal force, we can find our force of friction by timesing the coefficient of friction times our normal force. Okay, and then for any horizontal surface, our normal force is equal and opposite to our force of gravity. So Fn is equal to negative Fg. Okay, and so there's again a question on that, example on that. It's on page 259 of your textbook on how to kind of solve those problems. Okay, just depending on what you're given. Okay, so yeah, we just went through all the notes for pages 249 to 259. It's good to kind of read over those. You can kind of skip through different sections and stuff because it goes more in depth than you need. Okay, and then like looking over these practice problems, okay, they'll be helpful and it shows the answer. So like if you aren't sure how to do it, try one of those where you know what the answer is, and then that could help you. Okay, and so now we're moving on. Okay, we kind of know our formulas. Now we're going to look at like how the speed and affects the motion of a roller coaster car and so on. And so like it's basically how centripetal force and gravity are affected by each other. Okay, and so when you think if you're going through like a loop-de-loop in the roller coaster, okay, in both cases, like your Fn and your Fg are pointing down because your Fn is always perpendicular to the surface, and then your Fg is pulling you down. Okay, and so in this case, like your centripetal force is going to be both of these that are pulling you down. So basically, the faster the car goes, the more centrifugal force is required to keep it moving. Because like if the car goes around, if it's moving more slowly, the centrifugal force required is only 1,000 newtons compared to 2,000. So again, this is out of your textbook on page 261. Okay, and so basically what we're saying, like when we came up with the formula for force is dependent on your velocity. So the faster you go, the more centrifugal force pulling you down. And so if you aren't going fast enough, okay, that's when bad things can happen. So if it goes around the track even more slowly, so like again, your FC has to at least equal your FG, or else it's not going to go fast enough to go around the circle. Okay, and so yeah, like since the normal force cannot pull upward, it cannot generate the positive 200 newtons. So, and we need at least 1,000 newtons. Like our FC has to at least equal our FG for the roller coaster to go around. Okay, and so yeah, we need 200 more newtons to keep on the track. So we'd have to speed up our car so it doesn't flip off. Okay, so the slowest that any car can go around the track would be at the speed where only the weight of the car provides a centrifugal force. Okay, and so again, there's an example on page 262 on how to solve these problems. Okay, a vertical system in circular motion. So if we consider a pail of water that's swung in a vertical circle, okay, for these types of questions, okay, so again, as we're swinging in the circle, okay, this would be force of tension, okay, and then force of gravity. So when it's at the top, they're both pulling down, okay, and then the force of gravity would change at the bottom and so on. Okay, but in this case, as it's going around, our force of tension plus our force of gravity will equal our force of centrifugal motion. As this moves around to the side, then our force of centrifugal force would be equal to the force of tension. Yeah, and then at the bottom here, okay, our centrifugal force, again, is equal to our force of tension plus in this case, our negative Fg. And another example is on page 264, and it explains to you kind of how to go through the process of these questions. Okay, and centrifugal force, acceleration, frequency. So most devices that rotate with really high speeds report the frequency of the rotation rather than the speed. Okay, so like drills and saws. Okay, we talked about the hard drive, so it's a lot easier to instead of saying like 0.008 seconds, we just say a frequency of whatever it was, 200 or 120 for our hard drive. Okay, and so in this case, velocity is proportional to our radius. The larger the radius, okay, the larger the velocity. Okay, and so just kind of looking at this, oops. Okay, and so A is going to move faster because it has a smaller radius. Or sorry, A is going to move slower because it has a smaller radius. Compared to C, all of these need to make one rotation the same amount of time. The further out you get, okay, the faster it has to go to make that one revolution. Okay, and so yeah, the speed is proportional only on the radius. The time is going to be the same. They all need to get around and line up. It's not like C can move independently of A and B. They're all going to move equally. So points further from the center have to cover a larger distance or larger circumference over the same time period. Okay, some of the formulas that you'll need, okay, and kind of how to manipulate them. Okay, all of these are given on your formula sheet. So like if you're given, if you want to find acceleration, the centripetal acceleration, and you don't have v, okay, you can just substitute v in here, and so you got basically you're substituting this in for v, and this is the formula you come up with. So because you're squaring everything in here, so 2 squared is 4, pi squared you get here, and then r, because it's v over r is divided by r, that cancels, because this would be r squared divided by r, you get r, and then divided by t squared. Okay, same with for centripetal force, you can substitute now this in for your acceleration formula, and then you're just timesing it by the mass. So just another way to use the formulas depending on what you're given. And that's why with any of these, and you'll see in this example, but any of these problems that you're getting, the biggest thing, follow the graphs method, write out what you're given. Okay, so are you given the v and the r, then it's fairly simple. If you're not, if you're given the r and the t, then you're going to use this formula depending on what you're trying to find. Okay, so write down what you're given, what you're required to find, then choose the right formula based on what you're given and required, and then analyze and solve for the problem. All right, so your assignments, again, you can kind of read through these. These are all the questions out of your textbook for that section. Okay, you're going to have a couple of assignments, so you don't have to do any of these problems, but they're always good to look at and kind of see what some of the questions that are based on this. Okay, and then I'll post the assignment up for you. There'll be 3 separate assignments based on this, and so that's going to take us most of this week, and then we'll get on section 5.3 next week as we go through this. All right, again, just remember to email me if you have any troubles, and we'll go from there, and we'll do a Google Hangout based on this stuff tomorrow or Wednesday.